All right, so the histogram shows the scores Mr. Anderson's students got on the final exam. Okay. By the way, do you guys know my little code up here? Do you care about my little code? Anybody? It's a really bright pen. Okay, so A is 2 points, B is 2 points, C is 2 points, D is 1 point, E is 2 points. That's how I break it down. That way I remember when I'm grading what I intended when I actually wrote it. Okay, so we have the scores that they got and the number of students that got this. I love how this line, some people tried to make it go to 10. If you draw that straight, that does not go to 10. I would approximate that as 8 or 9 people, right? Yes? Mm-hmm. Yeah. So we would say, do we want to say 8 or 9? I'm going to say 9. Is that okay? Mm-hmm. This one, it looks like less than half. I'm going to say 3. Yeah? Sure. This one looks pretty close to 20. This one, and you can always use a ruler if you really want to get fancy, or you could just fold up your test like this and go, okay, that is looking like 40, isn't it? Oh, yes, because my teacher wants to do it. And let's see, right there. That looks like it's a little bit above 20. I'm going to say 22, approximately. Yours may be off by 1-ish, 2-ish, but it should be fairly comparable there, yeah? Okay, so how many students scored below 40? By the way, I have to say approximately because these are not exact values, right? It's not counting by ones. You can't clearly see how much it is. So below 40 would be this box and this box, yes? 9 plus 3 is 12. Some people put 13. This pen's hard to see, isn't it? 12. There we go. That's a little better. 12 or 13 is what I have on my key. There were some people that put 15. I'm like, how do you figure that's 15? Well, you just kind of assumed that this was 10 and this was half of that, so it was 5. Be a little more precise than that, please. Okay. If anything over 60 is considered passing, that would be this bunch right there. How many students passed the final? Well, 40 plus 22 is 62. And my key says 62-ish. You don't have to write exact, you don't have to write the ish, but somewhere around 62, 61, 63, something like that. And then approximately how many students took the final exam? How am I going to find that? Add them all up. Let's see, that would be, I should probably get my calculator out, shouldn't I? 62 plus 20 would be 82, plus 12 would be 94. 94, 95, somewhere in there. Yeah? Okay. Is this data skewed to the left, skewed to the right, or approximately symmetric? Well, I'm hoping that you recognize it's not symmetric, correct? Yes, because it's not a mirror image on either side. If you were to draw the little like that, where would the tail be? The tail is on the left. The tail tells you what side it's skewed towards. So this is skewed left. So the tail side is where the skew is. Okay. What does the skew or symmetry tell us about how students generally performed on the final exam? Explain your conclusion. Full sentences in answer. So I would say something like, students did well on the exam because of the left skew. More students passed than didn't. Most of you said something to that effect. right? Include something that says because of the skew, or something like because of the left skew or something, because the question is asking, what is the skew saying? Now, if it was skewed to the right, what kind of a conclusion would you make? They did worse. If the bigger bars were on the left, that would mean they would have had the lower scores, correct? All right. The data listed is the number of televisions in 25 households. So I think I need to go 0, 1, 2, 3, 4, 5, 6. Yes? So let's see. Please label your list like this. Okay, I make sure that there are enough spaces for you to label those. And then, as lame as it sounds, I actually did count your dots or your X's to make sure you had the appropriate number in each row. There were a couple groups that missed a few, so be careful with that. One other thing is try and make, I know this is really particular, maybe I can figure out how to do it on the computer tomorrow, but try and make your X's or your dots the same height. Because if you do some big X's and some low X's, it's going to mess up how high your columns are. Does that make sense? And it might make it harder to tell if it's skewing one direction or not. And if that's going to be a problem, then just do dots. But make sure they're dots I can see. Gosh, Franken, you're asking way too many questions. So I'm going to use dots, but do dots like that so I can see. So 3, 4, 6, 1, 3, 2, 4, 5, 0, 3, 2, 1, 2, 5, 1, 2, 3, 3, 4, 4, 3, 2, 4, 3, 5. So I have 1 dot, 3 dots, 5 dots, 7 dots, 5 dots, 3 dots, 1 dot. Now, that should be pretty clear as to what's going on here as far as a skew. What are we talking about with a skew here? We have a symmetric. And we intentionally made it exactly symmetric so that there were the same amount of dots here as here. You might not get something quite that perfect in real life. Doesn't happen all the time, but we do have our symmetric there. Questions about that one? Good. All right. The mean grade on the final exam was 68% for the 430 students enrolled in IM 3-2. A class of 31 students had a mean exam score of 71%. Identify the following as population, parameter, sample, and statistic. Okay? Well, 2 of these values are percentages, correct? And 2 of them are actual number of students. The percentages are going to be either your parameter or your statistic, which means that the student numbers are either going to be the population or the sample. So if I look at the 2 student numbers, which one is the population?
430.
The 430. Which means the 31 is my sample. Right? Now, remember what I said about S goes with S, P goes with P? So I need to ask myself, 71%, is that a piece of data from the sample or from the population? A class of 31 students had a mean score of 71%. It's from the sample, isn't it? It's from those 31 students? Yes?
Yeah.
So if it's from the sample, that means it's the statistic.
How do you know that? How do you know that?
Because it's the percentage from that sample. That's the conclusion they were able to get from the sample. The conclusion then for the entire population was 68% because it was 68% for the population. So that makes this your parameter. Yes?
Basically, whatever data end up getting for the population, for the bigger number, you put with the parameter or whatever data you get for the smaller number, you put as a statistic?
Yes, that's what I mean by P goes with P, S goes with S. Your statistic always is information about your sample. Your parameter is always information about your population. Okay? Any other questions there? No? We good? All right. The box plot shows information for two sets of data, set A and set B. Estimate an interval for set B that represents 75% of the data. So when we're looking at box and whisker plots, how is the data broken up? When I'm looking for 75%, how am I going to know what 75% is?
Minimum.
Okay, so this whisker right here represents what? 25%. This first box? 25%. This
25.
and my last whisker?
25.
25%. So each part is 25%. So if I'm talking about 75%, I am talking about 3 parts, correct? There's only 2 ways I can come up with 3 parts. I can either say, we're looking at B, right? I can either say 1, 2, 3. I can either say that range, right? Or I can say that range. Because each of those are 3 sections, right? They have to be consecutive sections. You can't just bounce around and go this one and this one and this one and have a hole in the middle. That doesn't work. So I could either have written somewhere around like 3 to 13 was acceptable. Or if I went on the pink one here, that would be 6 to 15. Now you don't need to write both of those. You just need to come up with one of those. Okay, but if you say 3 to 15, I'm going to have an issue. Because 3 to 15 is the entire range. It's not 75% of the data. It's 100% of the data. Okay? Which data set, A or B, has the smaller IQR? A. Why? On the graph, just looking at that, without even doing the Q3 minus Q1, how can you tell A IQR is smaller?
The box is shorter.
The box on A is shorter. Longer the box, longer the IQR. Okay? So? All right. You want to find out more about what the shopping habits... That's a really terrible sentence. You want to find out more about the shopping habits of the students in your class. Is that better? I either needed to cross out what or put R at the end. Now, this was one where I got a little particular because what does question A say? Write one question you could ask each student if you wanted numerical data. And so that's basically asking you to write a question that you would put on a survey that you would give out to people, right? And there were a lot of people that said, how much money do people spend shopping? Yes, that is numerical. By the way, please put a question mark at the end. There were a lot of people that didn't. I recognize that's very hard to read there. But if you received a survey and this question was on there, let me rephrase that. If I received a survey and this question was on there, my response would be, how do I know how much people are spending? I can only tell you how much I'm spending. So if you are writing a question for a survey, you can't ask them to make some conclusion about people in general. That's what you're trying to do at the end of collecting all your data, right? The only thing I can accurately say is how much I would spend. Does that make sense? It's a tiny little change in the question, but it shows a little bit different level of understanding of what you would do to prepare. So that was the most common one that people wrote, was about spending. So you would say something like, how much do you spend when you go shopping? Okay, so there. Write one question you could ask if each student, if you wanted categorical data. So this was numerical because their responses would be some amount of money, right? $25, $50, something like that. Write one question you could ask of each student if you wanted categorical data. Now there were a few different things that people asked. People asked, what do you shop for? That's fine. Do you shop for clothes? Do you shop for music? Do you shop for... I guess people don't go out to shop for music anymore. They just download it on their phone. But you get what I'm saying, right? Something that I was thinking would be something like, which stores do you go to when you shop? Anything that might have a word answer more so than a number answer would be acceptable there. And again, just make sure it's a complete sentence and make sure you end it with a question mark. I know I'm not an English teacher, but I do speak English, so I like it. So I would say something like, I could even say, what is your favorite color? Doesn't deal with shopping habits necessarily.
What is your favorite color shirt?
To buy. What is your favorite store to shop at? Okay. Explain whether you would take a census or a survey and why. This one was interesting because I thought this was kind of a no-brainer, but there were a lot of people that got it wrong. By the way, these are 2 points apiece. You want to find out about what's your population?
Your class.
Your class. If it's just your class, you would take a what? I would take a census. Because why?
The class is small, so it's easy to get all of the data.
Sure, you can write that much if you want to. Isn't that big? I would say something like that. The population isn't that big, that's why I'd take a census. Remember your rule in general, if you can take a census, great. When would you not take a census? The population was too big, it was too expensive to get a hold of all of them. Taking a census would destroy the population. Remember when we were talking about like quality control stuff? Okay. Any questions about the front side before I turn it over? Back side goes a lot faster. Yeah? All right. So here is a data set. Identify the following: mean, median, mode, range, standard deviation, 5-number summary. Okay, first thing I'm going to do is I'm going to put these in order. I don't need these in order for all of these, right? But I do need them in order for the median, for my 5-number summary, and therefore my IQR and my box and whisker plot, right? So let's see, I have 3, and then what? I have 3 4s. 4, 4.
And then
5, 6,
8, 10,
8, 10, 10. Now, I always go back and count my numbers because knowing me, I will forget one and it will screw every little piece of data up, or every piece of information there. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, got them all. Whew. All right, the mean. How am I going to find the mean? Add them all up. Plus 5, plus 6, plus 8, plus 10, plus 10. And divide by how many there are, which is 9. And my mean is 6. Median. What's right in the middle? If I go and I work my way in, Looks like 5 is my median. Yes? What's my mode, my most popular? 4. Now, what if there was another 10 on this list? 4, 10. 4 and 10 would both be modes if they were both equally popular and they were both more popular than everybody else. 10 is not part of the mode, though, because there is somebody more popular than him. Range. How do I find the range? Max minus min. My range is 7. Sample standard deviation. I'm going to come back to that. Right now I'm going to do the box and whisker plot and the 5-number summary, all that good stuff. So I have my minimum. I have quartile 1, quartile 2, quartile 3. What is the minimum? 3. Maximum is Q2 is 5, because that was my median, right? Now, do I use the 5 with the left side or the right side?
No.
Neither. Drop it off your list. Right? Remember, if there was like 1, 2, 3, 4, if that was your list and your median was right there, there's nothing to drop off your list. So you just count everything here for your Q1 and everything there for your Q3. Make sense? But this one's different because that one drops off. So if I look here, what's the median of this size?
4.
It would be right there. Between 4 and 4 is 4. And on this side would be right there. What's between 8 and 10? 9. My IQR would be Q3 minus Q1. That's 9 minus 4, which is 5. So far, so good? Now, my box and whisker plot. What do I need to include on my box and whisker plot? Well, I need to get from 3 to 10. So I'm going to go 3, 4, 5, 6, 7, 8, 9, 10, and there's some extra lines. Oh well. There will at least be as many lines as you need. I did have one group that put their box and whisker plot like on here, like they made their box right here, and then their whiskers went like this. It's really hard to see the whiskers when they're on the line, right? Like from a grading standpoint, that's really hard. So please put your box and whisker plot above there. So let's see, I fill in my points. 3, 4, 5, 9, 10. And again, my secret method for this is draw vertical lines through the middle 3, connect them, and then your whiskers. Okay? So? Now let's do the one that's a pain in the butt. It's a pain in the butt, but it is worth 4 points, so I don't want to skip it. Standard deviation. I know I need the mean. What am I going to need to do? I'm going to need to take each number on my list and subtract the mean, and then square it, right? And then I'll do some stuff with it after. So I have 3 minus 6, which is, actually, you know what, let me write them all down. 4 minus 6, 4 minus 6, 4 minus 6. I'm going to run out of room, aren't I? 5 minus 6, you do need to include that guy. 6 minus 6, 8 minus 6, 10 minus 6, and I'm running out of room, so I'm going to put the other 10 minus 6 up here because order doesn't matter with our standard deviation, does it? So I have 1, 2, 3, 4, 5, 6, 7, 8, all of my 9 values. So 10 minus 6 is 4. 3 minus 6 is negative 3. 4 minus 6 is 2, 2, 2, 1, 0, 2, 4. Yes? Now I square them. 4 squared is 16. Negative 3 squared is 9. 2 squared is 4, 4, 4, 1, 0, 4, 16. And I add them all up. Yes?
Yeah.
Okay. So, 16 plus 9 plus 4 plus 4 plus 4 plus 1 plus 0 plus 4 plus 16 is 58. And my last 2 steps, I divide by what? 9
8,
Minus 1.
right?
minus 1.
Oh, yeah, you're right.
and then I'm going to take the square root of that. So that would be 58 over 8 square rooted. So 58 divided by 8 is 7.25. Square root of 7.25 is 2.69. If it's population, you just don't subtract by 1. Correct. I believe on the test we just keep it as sample because that's the most common one you would use anyways. Okay? We good with that?
Yes, ma'am.
All right, now we get down to matchy-matchy. Now, reminders. Self-selected is what? People choose to participate or not. Systematic. There is some kind of a system to choosing the people participating, such as every fourth person or every second person. Simple random, you want to think about that as everyone has an equal chance, such as putting names in a hat and drawing names. That's the most common one. Stratified, you have a bunch of groups and you're going to do what? Choose some from each group. Cluster, you have a bunch of groups and you choose a couple groups, right? Convenience, people closest to you, easiest to get a hold of. So, you want to know how many people in your math class have a job. You ask 3 sophomores, 3 juniors, and 3 seniors if they have a job. What do we have? Stratified. What are the groups? Sophomores, juniors, and seniors, and you're picking some from each group. So we have stratified. All right, you want to know how many people in your math class have a job. You put all the students' names in a bowl and pick 8 students to complete your survey. Simple random. Anytime you're putting all the names in a hat and drawing some, names in a bowl and drawing them, you have simple random. You want to know how many people in your math class have a job. You pick 2 rows to ask, and you ask everyone in these rows. Cluster. What are the groups that the class is split into in that case? The rows, right? Group 1, Group 2, Group 3 are your different rows of the class, and you're picking a couple of rows. You want to know how many people in your math class have a job? You ask 5 people who sit near you. Okay? You want to know how many people in your math class have a job? You ask to see the attendance roster and ask every 3rd person on the roster. Yep. Whoop. Systematic. There is a system. You want to know how many people in your math class have a job? You put your Twitter handle on the board and ask the class to direct message you their answer.
At Jeffrey Murphy.
Self-selected. Why is that self-selected?
Because they volunteer, like they do it themselves.
Because whether they choose to go on and direct message you their answer tells that they are selecting themselves to be a part of your survey. Okay? Any questions? Happy studying.